Hi, my name is Noah Gift, and today we're going to talk about energy operations. I call it energy ops. There's a lot of technology terms around DevOps, which is doing software development best practices. Taking your code, automatically testing it, deploying it into, let's say, a cloud environment. There's also ML ops, where you're taking machine learning models, fixing maybe aspects of those models, making the data cleaner, and then automatically deploying that into a feedback loop. But there's a new emerging type of technology called energy ops. And what energy ops is operationalizing the aspects of clean energy. So this could mean using solar power with battery backup. It could also mean using your mobile devices to interact with all of these solar technologies, and also how do you design a system so that you have a smart home that intelligently uses, let's say, a thermostat, uses a good battery charging mechanism from your solar system, and how do you put all those things together to come up with a comprehensive solution for commuting, going to grocery store shopping, and then also keeping your costs low. So this is really more of a conceptual idea, and we're going to see a lot of these technologies emerge in the next 5 years. Many large automobile manufacturing facilities are going to switch completely to solar and electrical friendly technologies. So this is really a great time to get more familiar with it, and then really have a heads up on how to use these technologies to both make more clean energy available and then also to lower your costs. All right, let's go ahead and get started. Let's talk through several of the key components of operationalizing energy use. One of the things to be aware of is that the grid is how most people get their power. And so this grid could be powered by, let's say, coal, or it could be powered by clean energy, or natural gas, or some other source. And the more important thing to know is that when you're developing your own energy operations solution, is that you can choose to actually not make the grid part of how you use energy. And this really starts with your home first. And so in order to get this set up so that you don't need to use the grid, what you can do is develop your own solar technology. And so if you develop solar panel technology on your house, put that on top of your roof or maybe in your backyard. Potentially also you could use wind energy. This will start generating enough electricity if you buy enough panels so that you really are not dependent on the grid for most of your energy. Now, one problem that comes up though is that solar typically will have a bell-shaped curve of production. So in the middle of the day, let's say from 9 to 3 p.m., this would be the majority of where your production would happen. And so what do you do in the morning and what do you do at night? Well, you could still be dependent on the grid. And that's how many people will still generate energy, is that they'll pull the power from the grid during the morning time. Or an alternate route is to have more technology in your house. And one way to do this is to have battery backup. And if you have batteries installed, just like on your iPhone, for example, it's a really good example. Your iPhone allows your phone to, let's say, be used for a couple days. You can do the same thing. You can put in battery installations here, maybe 1 or 2 or 3. And in the case of Tesla battery backups, let's say you could generate about 13 kilowatt hours of storage. And you could actually store, let's say, a day's worth of energy. Now, what happens is that as that excess solar comes in, it gets charged onto your battery. So this is a lot like an iPhone where you charge it up, it gets to be used for a while, and then you have to charge it back up again. So your battery now can, while you're producing this energy during the middle of the day, store that extra in the battery, and then you can be completely independent of the grid, other than maybe paying a connection fee to the grid. And this is probably the optimal scenario for most people wanting to perform, an energy ops workflow or architect a new solution. And then even better, there's a couple things you can do to enhance your ability to communicate with the grid. And one of the ways is that you can actually do something called net metering. And with net metering, you can develop credits so that, let's say you've already charged enough power for your home, that's pulling in from the solar. You're already at a steady state. The extra is going to your battery backup. Now, what happens if you can't store any more energy? Well, what you can do is you can give it back to the grid via net metering. And so what happens is that they give you a credit that you can use when potentially the sun is not producing as much energy that you don't have to get a bill for in the future. And so really this is a great cost savings for the consumer, is that you can turn on net metering. Now, one other thing you can do is something called time of use. And what's great about this time of use plan is that when you do time of use, you can also optimize for the same scenario here. So let's say in this 9 to 3 range, that's when most people are turning on their AC. They're maybe doing laundry or some other action in their home, doing work from home. Well, your electrical company may decide to give you a higher charge. Let's say they charge 4 cents a kilowatt hour for that energy or whatever it is your electric company decides to charge. And then maybe later in the day, when it's non-peak, let's say it's at 3 p.m., you'll actually be charged, let's say, a penny, per hour for a kilowatt hour. And so what's great about this is that you can decide using your mobile technology how to actually tell your system to work. And in fact, the Tesla battery backup system has something called time of use, and you can tell it to emit the energy when there's a peak range, right? So that you never have to pull from the grid, and then it can store energy when the battery is much more efficient to charge, and you can get that energy, let's say, from the grid, or you could actually get it from your own solar production. So that's one of the other things about operationalizing energy, is to be aware that if you do have a battery backup system, it enables you to create many different workflows that are much more difficult to achieve without these technologies. Now, further, one of the things that happens with this energy operations scenario here is that you can start to get your car also as part of the loop here. And so what's fun about this is that if you convert to an electric vehicle, and there's many electric vehicles now that are, let's say, $10,000 to $20,000, relatively inexpensive, what you can do is you can also tell your car to treat your home like it's fuel station. So you could completely eliminate all trips to the gas station, especially if the majority of your trips, let's say 80% of your trips, are under 100 miles or so. There are many used electric vehicles that can easily do this, and that's one of the great things about using your home actually as your primary source of energy. So with an energy ops scenario here, your car can also tap into that same situation. So if you have battery backup and you have solar and you have the net metering and time of use plan set up, it really gives you a lot of flexibility about how to completely optimize for your cost. Now, where does mobile come in? Well, one of the ways that the mobile technology comes in here is that with mobile technology, you can also develop something called a smart home. And with a smart home, you can install thermostats like the Nest thermostat, for example. And this Nest thermostat can actually predict, based on the normal usage that you have in your house, when the electricity should be used more or less. And it can also do things like detect patterns and then lower your energy usage. So when you start to combine a smart device as well, then really you as the user with your iPhone or your Android device can completely control and architect an energy operations workflow. And in this scenario, what's so powerful about it is that you're able to dramatically decrease the cost that you normally would pay for energy. And also you, as more of a logical thinker or a software engineer, can go through here and architect a similar kind of a scenario that you would with software or machine learning. And so really this energy operations is an emerging field, and it has a lot of capabilities that a traditional knowledge worker, tech worker could tap into. And we're just getting started with all of these capabilities. Let's take a look at how a battery backup system integrates with a complete energy ops solution for your home. to start with, I have a Tesla application here, and notice that it says that it's at 100% capacity. So what we can do is we can click on power flow here, and you can see that the solar energy currently is 0.7 kilowatts an hour, and then we're getting about 0.4 kilowatts an hour from the grid, and then the Powerwall itself is supplying 0.2 kilowatt hours to the home. And so you can see it's dynamic. Things are constantly changing, back and forth here. And then as the home and the Powerwall kind of shut off for a second, and I don't need to supply energy back to the house, the solar energy directly goes back to the grid. And this is where that time of use and also a net metering comes into play, because the more energy that I can give back to the grid, the less energy I'll have to pay for in the future if I have a lower amount of solar production. Again, let's say a different time of the year, like summer or something like that. Now, that's really the dynamic system, and you can see how it works back and forth. Now, let's take a look at performance itself here. So one of the things that you can do is you can actually see what the performance was during the day, and you can see that 46% of the power was supplied by solar, and that 0% was by the Powerwall because it's been charging the Powerwall. And you can also see the offset here. So you can see that the home only consumed about a half a kilowatt hour, but the solar itself generated 13.7 kilowatt hours. So what I can do as well is that I can go back to this, and I can also look at more of like a week overview here, and you can see that now things are equally split between the solar and the Powerwall, and you can see that the home itself was only consuming 20 kilowatt hours, but the solar system generated well in excess of what was necessary. So that's a great way to get an overview of kind of what's happening here. Now, another thing you can do as well when you're looking at your system is that you can go to this customize dashboard here, and what it does is it shows you the different modes you can put your Powerwall on. One of the ways you can use your Powerwall is as a backup only. Let's say if you live in a state where there's frequent power outages like California, and you're very concerned of having maybe a multi-day outage, well, you could select it to be only backup, and then your Powerwall would only be used for backup. Another one is self-powered. Let's say you live in the mountains somewhere and you really want to 100% use your energy that you've got stored. You don't want to depend on the grid at all. You could pick mostly self-powered. The one I think that most people are probably interested in is this time-based control. And that's what I have currently on my house because I have net metering and I also have time of use. And what this means is that you have a couple different options here. One is that you have a balanced mode, which uses the stored solar to power your home when electricity is expensive and after the sun goes down, or you have a cost-saving mode where it's really optimizing for your time of use plan. Now, how does it know when to pick out which is the correct energy source to use? Well, if we look at this edit price schedule here, let's take a look at it. Notice that what it does is it allows me to set what the peak time is. And so here we can see during the week that I'm setting the peak time to be 11 to 8, and I'm setting the off-peak time to be 8 to 6. On the weekend, same thing. We can see that the peak time is 11 to 8, and off-peak time is 8 to 6. Now, it's inferring that this gray area over here is actually a shoulder time, and what that means is that it's actually not it's more of a medium charge, but the peak charge is the one that's, let's say, double or triple or quadruple what you normally get charged. So what it does is it uses this schedule to make decisions about which energy source to use. In the case of peak energy, you would want to optimize first for the solar power, and then second, you'd want to optimize for the energy that you've used maybe that's already stored in your house. And then the last thing you'd want to do would be to go to your grid scenario. So what we can do now is look at this performance mode here real quick. And one of the cool things about it is that, again, you can look through here, you can look at all the different energy sources, partial peak, peak. But I think one of the best ways to look at this is to kind of see how this thing is actually displaying your energy in terms of the breakdown. And so if we click on this icon here, what it does is allows us to toggle between the different modes. And so we can see that today the home itself used a total of about a half a kilowatt of energy. Now we can also overlay this with the grid energy, and notice that you can see that, the solar energy. You can see that the solar energy is really peaking between 8 to, let's say, 4 or something like that. And if I flip to yesterday, that gives us a better overview, and you can see that this is this bell-shaped distribution. That's when the majority of energy is used. And if I take off the actual home usage, you can see that the solar energy that was generated was 14 kilowatt hours, but the home itself only used 2. So there's an extra, let's say, 12 or so that we can do something with. So where would we do things with this energy source? Well, what we could do is we look at the power wall here, and you can see that the power wall was actually being used to supply the home, and it was actually generated about 7.2 kilowatts of energy to the house yesterday. And you can see that then from 8 o'clock to 4, it was actually being charged back up again. And this was being charged by the solar energy itself. And this is one of the great things about having the ability to dig into the details on your solar system, is that you can choose exactly how to design your system so that you have the lowest cost and have the least dependence on the grid. Now, another thing you can do here is you can go and click this grid, and you can see that the grid itself was only used about a half a kilowatt of energy, and most of that was actually used during this period where there was a little bit of a spike actually in the morning and at night. And notice that those are off-peak times. Notice that during the peak time, look at this, I'm actually giving energy back to the grid. And in fact, I'm actually getting a great credit for this, because let's say it's double the rate that I normally would get a credit for, because when my power company wants the power, I'm giving it to them at the time that they want it the most. So there's a lot that you can do with a home solar system here, and this shows you some of the ways that you can integrate it with your iPhone. Okay, let's look at electrical vehicle charging. Let's demystify it a little bit. If you have a regular home, you have 120 volt outlets all over the house. That's how you plug in, let's say a blender. And you can take your electric vehicle without doing anything different, and you can plug it in, and it will take, let's say, close to 24 hours or maybe even more to charge it in. But depending on what you're doing, how much you use your vehicle, that might be okay. And in fact, again, if you want to interact back and forth with your solar plus your battery system, here you basically have free energy, and you never again have to pay for gas, which is a huge win. Most people, though, want to charge a little bit faster, and so what they do is they install a level 2 system. And all this means is that it's got a 240 volt outlet, and it looks like the same outlet that your dryer plugs into. You put one in your garage, you attach a charger to it that's, let's say it's like $500 or so, and it can do some smart things, like it can tell your car to only charge at night, and that will maybe make your time be a lot quicker, let's say 4 hours. For most scenarios, the level 2 system is probably the way to go if you have solar, and you can tell your solar installer to put that as part of your package. And of course, you can write this off on taxes as well. Now, a level 3 charger, what's fascinating about this is that with a level 3 charger, you can charge your car in, let's say, roughly 30 minutes. They can go as high as 800 volts. This is still emerging technology, and this is where a lot of the grid across the United States, where people are trying to figure out how to put new types of fueling stations in, that they're thinking about these level 3 chargers. Your car has to be capable of using it. The Teslas are a good example. These Tesla vehicles can use the level 3 charging, but also vehicles like the BMW i3, which is a vehicle I have, that BMW i3 as well can plug into these level 3 chargers. So this is still an emerging space, but most of the time I think you're going to be happy with a level 2 charger, and that's the one that I I would recommend you integrate with your home system. Okay, let's take a look at what the vehicle side is doing in a energy operations workflow here. One of the things that we can see is that I have a BMW i3, which is an EV vehicle, and notice that we can see that the charging is happening. That's doing level 1 charging, and with level 1 charging, it's going to take quite some time, but you can see that it's at 84% capacity. If I had a level 2 charger, if I plug that into my Tesla battery backup system, it would be a much faster rate. And also, we can see that there's a starting time and an end point. So how would you then integrate this with the rest of your system here? Well, one of the ways to do this is to integrate how you charge with other parts of your house. And what I'm going to do next here is I'm going to go to a Nest app, and you can see, if we go open to this Nest app, that I can select between different properties. Let's say I have more than one house and I want to go back and forth. I can choose which property that I want to go to and decide how much power I want to pull from, let's say, the energy system. And in this case, maybe the air conditioning itself, because the car needs to draw energy and the air conditioning needs to draw energy during peak time. I could calculate the correct amount of energy usage that I want my house to use and make that all as part of the forecasting for how to have zero carbon footprint. And let's take a look at this thermostat here, and you can see how it can be part of a clean energy solution. And one of the things I can do, if I go to these advanced settings here, is I can say I want auto learning on. And what this learning does is it allows me to use lower energy, because it can pick how to actually automatically lower the energy based on what are my patterns. Another thing I can do is it's got eco temperatures as well. And notice under these eco temperature settings here that I can choose to create a much higher temperature if I needed to in order to lower my energy costs. And so these are all ways that you can actually choose to do scheduling and lower the energy costs. And then you can combine that again with your let's say your charging system here. And that's what's great about really combining all of these systems together, is that you can choose how to orchestrate an entire system, just like a software system, and it's all done through mobile technology that your house has the capabilities to use. So that's it. We talked about energy operations and how to operationalize a bunch of different features, from your house to your solar system to the energy grid to battery backup to mobile devices to an electric vehicle. And also one of the things that's going to happen in the future is how can you coordinate that between maybe multiple places that you live or multiple places that you live and work, and then also how does that work with trips that you take. So there's a lot of interesting things that just a regular person can do to optimize their energy footprint, to lower your costs, and also really use some of the skills that you're already using as a software engineer or technical person with clean energy. And so it's actually a very exciting time to be involved in all of this. And we can see that in the future, there's going to be more artificial intelligence that's associated with it. For example, if we could know more about the weather patterns and we can feed that energy data into our house, we could make projections about when we should charge, let's say, our battery backup system, how much energy we should give to the grid, how much energy we should keep, when are the times that we should charge our car, what are the different levels of air conditioning that will be comfortable. All of these things are going to be part of AI solutions that get tacked onto what I call energy ops. And it's an exciting time to be involved with all this new technology. And I think the only thing we can bet on is that things will not stay the same. Most automobile manufacturers in the next 5 to 10 years are going to phase out all internal combustion engines. And so it's going to be a very exciting time to be an expert in the operationalization of energy. All right, talk to you later.